What's happening, folks? Thanks a lot for joining the Altered Perception Show. Today we have Shelby Heinecke with us. She has a PhD in mathematics from University of Illinois, Chicago, and she has also been in MIT for her undergrad program. Currently, she is with Salesforce for the last 5 years, I believe, and she's working as a senior AI research manager over there. She has done a lot of work in AI ML space, especially in her PhD career. At the same time, in the Salesforce, and she is totally up to date with the agentic AI. You know, interfaces and agentic AI systems. So I'm super excited to learn from her all about AI agents and all about what the future of the agentic system holds. Because I've heard that that's a gateway to get to the AGI. So I'm super excited. She's also a CrossFit trainer, and so we'll learn the secret of how she manages all of this, how she juggles everything. But
Yeah.
all that said, thanks a lot for joining the show, Shelby. I'm super
Thank you.
excited for you.
Yeah, thank you so much for having me, Gaurav. Really excited. As you mentioned, we have a lot to talk about today because everyone's talking about AI agents. We're making a lot of good progress, but we've got a ways to go. We've got a lot of work to do. So really excited to dive into some topics.
Yeah, and let's start with that. So Salesforce, right? I mean, Salesforce is so big into agentic AI, and
Yeah.
even the CEO has said that you guys have a goal of building like more than 1 billion agents, which is
Mm,
like bizarre to me. Like, how do you even do that?
yeah.
Um,
Yeah. So the interesting thing is we've been thinking about agents for so long.
yeah,
And specifically my team. So I lead a research team, and the goal of my research team is to think ahead for the customer. So we're always thinking far out. We're not restricted to 3-month deliverables. We can think 6 months, years out. And so the interesting thing is we've been thinking about agents since I want to say spring 2023. So it's been a couple
that's
of years,
yeah, that's
and
very
you and
early.
yeah, it was a while ago, right? So long time ago we were thinking about agents, and yeah, so we released, Salesforce has Agent Force, I think, released, I guess the first version was probably last year, 2024. So yeah, fast forward, we have Agent Force 3 that was recently released. So yeah, we're making progress on agents, but the research of it and the thinking and um you know what it took to build it started far before that. Yeah.
Yeah, yeah, yeah. It's I mean, having that vision, even just like thinking ahead, and like you said, spring 2023. At that time, it was just chat gpt, and not even like the people who were like underground AI ML developers knew that there's going to be a thing called agentic systems. And only when Andrew Young publicly said on Twitter, and sometime in
Hmm.
early 2024 even, he said that that's when
Hmm.
like actually paying attention to it.
So I want to go. So if we go back to 2023, to your point, exactly 2023, we were still thinking about LLMs. We were still thinking, how can we get the LLM to write an email? How can we get the LLM to write a document? We're still thinking about that. But I want to say there were early signals, even in 2023. If people listening look this up, baby AGI was released. Also, something called Auto GPT was released.
Yes.
Early prototypes for agents, right? Both of those were the goal. The point of those libraries was it it was basically like a system that could continually call an LLM over and over again sequentially, and that's kind of like the first steps to an agent, right?
Yeah.
So those ideas were just starting to emerge at that time.
Yeah, and also the even GitHub has a GitHub Copilot. I think that you can categorize as somewhat of
Yep.
an assistant and agent in a way.
Exactly. Yep.
So
Yep.
let's actually take it to the level one. Like, what is agentic AI? What is AI agents? And for like, if you
Yeah.
can dumb it down to like layman's term, how would you define
Yeah.
it?
Yeah. That's a really great question because we hear so much talk about AI agents. So before we talk about AI agents, I think let's make sure we're all on the same page on LLMs. I think we are, right? I think we all understand how LLMs work, right? You put in a prompt, but that prompt is usually something like write this email for me, write this doc for me, write this text for me, write this copy for me, right? We can pass that to an LM, and LM creates that beautifully, right? LMs are amazing at this. That's just the first step, right? So what does an agent do? Now, an agent is an LLM system. It's a system, it's an LLM system. And the agent is continually calling the LLM over and over and over again to execute more complex tasks. So let me give you an example. Imagine we don't just want to write an email. We actually want to write and send the email. Not just write it, we want to actually send it afterwards. That is a task for an AI agent, because what an AI agent can do is take that task, break it down into easy steps. So in this case, the agent would ask the LLM. The agent would say, "Hey LLM, here's my task. What is the plan I need to execute that task?" The LLM would tell the agent, "Well, first we need to write an email. Second, we need the API call to actually send the email." Okay, so now the agent has a plan. So the first step in that plan is we have to write this email. The second step of this plan is we have to figure out how to send the email. And that means we need to communicate to the right app. So now the agent calls the LLM even more. So now the agent's going to call the LLM to actually construct that email, right? So in other words, the agent's writing the prompt that says, "Hey LLM, write the email for us." That email's done, gets sent to the agent. Now the agent asks the LLM again, "Hey LLM, help me communicate to the email app." And the LLM produces what we call an API, a clear way to communicate to the email app. And now the system can actually execute this. So this is how an agent works. It's really calling the LLM over and over again for thinking and for creating the steps needed to actually execute the task.
That's very interesting, and it's a really good description and example. Actually, it's the most basic example, but uh, traditionally it's been done by humans, and
Mm,
of course, we would want to have as much automation as possible, especially for the
yeah,
emails. Like, hey, just schedule this for like 1:30 p.m. or like, hey, can you
right,
please go and like book a flight for me, right? That's pretty
right.
basic examples, and that's where I see, like, that everybody should be using agent systems so that
Yeah.
they can automate their mundane tasks.
Mm-hmm.
But let's actually go a little bit more deeper into how do one even get started with like building agentic system. Like everybody knows how to use ChatGPT, Gemini, Grok,
Mm,
or like Claude or whatever you can, whatever you
yeah.
use to go and use the LLM, right? But what about the agentic system? I mean, not a lot of people like
Yeah.
non-technical know how to actually build AI agents. So,
Yeah.
what's your recommendation? How do you people even get started on this?
Yeah, I think there could be a couple of ways. So I think the most basic AI agent, it's so basic. It's kind of just chaining LLM calls together. So use the LLM to call one thing, use that output to pass to the LLM and have it do another thing. It's not really an agent. I don't want to call it an agent, but it's the primitive to an agent. So there may be ways for you to already, use an LLM a couple of times sequentially to get tasks done. So that's one way to get started on a primitive. But to actually I get a more sophisticated agent, I think there's more and more tools coming out. Like I can't even keep up with all of them actually, but I think for example, OpenAI has a more agentic version of ChatGPT now
Yeah, they call
available.
it
For
like
example,
operator, right?
yeah, they have some. They have very yeah. There's so many out there. It's hard for me to keep track of, but I would definitely recommend checking out. What user friendly tools are out there now. If you are at this level where you have a bit of coding experience, there's a lot of frameworks out there that you can build, not completely from scratch, but they have a lot of primitives that you can build on to build custom agentic systems. So I would say, for example, LangChain is one of the most popular frameworks that people are using right now.
Yeah. Yeah, and so you said LangChain as a framework. So what exactly does that do? Is that like is that a direct call to the LLM like a ChatGPT or Gemini?
Yeah. So the way a lot of these frameworks work is, like you have to still specify which model you want to use as the brain. So you can kind of think of LLMs as the brain of an agent. That's up to you to decide. It could be ChatGPT. You could say use Claude. You can say use any other models, whatever you want to use as the brain. They all have their strengths and weaknesses, and so you plug in whatever you want to LangChain. You do need to write some code though to specify For example, we talked about this before, what kind of tools or what kind of apps it would have access to. So remember, the LLM is just the brain. It just produces the steps to take. It might tell you which apps to use, but you still need actual access to certain apps to actually grab information from them. So for example, in LangChain, you could say, here is my feel free to access Google search, feel free to access this database and this database, assuming you have like the right, permissions and passwords to do that. So once you specify those things, so you specify the LLM, you specify the tools that you would have access to, that's kind of starting to set up the environment for the agent. Now the agent has a brain, it has things it can access. Yeah, I mean, that's a great starting point.
Yeah, and I think what you are describing also ties back to RAG, right?
Yeah.
Retrieval augmented generation. So wherein
Yes.
like you have the LLM, like you said, like a ChatGPT, Gemini, whatever one that
Yes.
you want to prefer, and then you have that as a brain, and then you can have a knowledge almost like
Exactly.
something that like a data which is almost like a knowledge source, and
Yeah.
then the LLM can use that knowledge source to communicate and then kind of find and retrieve information and
Yes.
then give it to the user and produce the final output basically, right?
Exactly. I mean, this is basically what an agent is constantly doing. It's just is doing it for multiple steps. So
Yeah,
imagine an agent maybe first step of the task needs to be to search and find 10 leads for me. So in some sense it is retrieval augmented because it's retrieving the information from Google and plugging it back into the prompt, right? To perform the next step. So yeah,
yeah,
these all ideas all tie together. Yeah.
yeah, totally. Yeah, and I mean, in layman's term, like, you go to like a travel agent, right? A travel
Yeah.
agent is constantly booking flights for so many different of their clients, right?
Yeah.
So it's like they're doing back and forth, right? They're going back and forth between the airlines, they're going back and forth between the end
Yeah.
users, and they're
Yep.
trying to like being a bridge a gap between both of them, right? So, and plus they're using their own knowledge, experience that they have
Yes.
collected, and as well as their own brains, I guess.
Exactly. I mean, that's basically, yeah, in your example, that's basically what an agent is, right? Like a
Yeah.
travel agent. Yeah, a travel agent is the real life version of what a digital AI agent is basically doing. It's using all these different tools or information sources, right? And kind of putting it together, gluing it together to get bigger tasks done.
Yeah. Um, So let me ask you this, like there are so many use cases that could be produced from this agentic AI, and people are saying that agentic AI can be so huge because
Mm,
that's where you can go off of just not just the foundation layer of ChatGPT or
yeah.
Gemini or any other LLMs, but also
Yeah.
actually do tasks which are like mundane tasks. And
Yeah.
what are like some of the examples you can give
Yeah.
maybe in your own work, or because you Salesforce is creating so many agentic frameworks and systems, right?
Yeah.
So if you can give some examples.
Yeah. I think the key that you just said is the ability to take action. That's another thing that differentiates the AI agent from an LLM. That I talked about that, implicitly in that example I gave, but that is really the key, that the AI agent is able to actually navigate an app, actually able to navigate a search engine, right? It's actually able to do this. So if once it's able to take action, that's powerful. Like it can actually do things potentially autonomously. I mean, probably right now we want to be reviewing what it does, but that's really unlocking autonomous automation, I think. So many use cases. I mean, you can look at any vertical and think about things that that you'd want to automate. I think there's so many different examples. I mean, for example, sales, are some very common examples, like finding leads, emailing those leads, sending updates, all of that. So as long as your agent has access, say, to Slack, has access to email, has access to a search, has access to maybe other sources, your agent can pull all of this stuff together for you.
Yeah, and you have made such a great point because talking about like the automation integration is such a key component of all of this, right? Because as you
Yeah.
said, like you have the LLM as a
Yep.
brain, but that brain will not be able to operate if it doesn't have the
Yes.
memory or the experience from the past.
Yeah.
and that experience can be you can retrieve this experience from like Slack, from like
Yep.
Google Drive.
Yep.
All the information that you can find in the Google Drive,
Yep.
this the brain or the LLM can fetch it. So this
Yes.
integration is such a key component of what
It
is not
is.
what. Then I also want to ask, like, I mean, so much of what we have, like for example, in like in our file folders, where let's say suppose you're talking about the enterprises where who are actually using so much of the data that they have, and
Mm.
let's say suppose they use that much of data to kind of help or get the help from the LLM to get the necessary output. Like
Yeah.
so much of data, how do they even get started? Like can they just directly get started with the data that they have, or do they have to clean the data? um,
Oh, okay. So yeah, I think this is a big one. So one principle to remember is garbage in, garbage out.
right.
That applies to so this is something we said back in the old days of machine learning, right? In machine learning, you knew that data was everything. It's no different for AI, right? It's the same thing for AI. So you put junk in, don't expect the most brilliant answer out. So the data is everything for AI, actually. I think we have amazing models. ChatGPT is amazing, right? We have these amazing models being developed. And you know, what I'm trying to say is that not all of us need to reinvent that wheel. Like there's a lot, so our attention doesn't need to be on generating a new model. There's already amazing models we can take advantage of. Our energy should be focused on cleaning up our data, really thinking about what data, or we call context, is needed to be passed into the LLM. That's where a lot of our effort really needs to be placed.
Yeah, I agree with you totally. I mean, having a data is one thing, and like having a clean data so that you can get the output. And that's
Yeah,
where the difference between getting the efficiency of the agent from like 60%
yeah,
to like 90%. So
yeah,
people can say that, oh well, I tried agentic systems and AI agent, but it didn't work. Well, it didn't work
yeah,
because the garbage in, garbage out.
yeah,
You put in the wrong or false data, or like the data that was incomplete or not
yeah.
clean, and then you get the output based off of that. So you cannot just blame the AI technology.
So it's not, and the other thing is, it's not, so data quality is one thing, so it has to be clean. But I think one thing that I've been thinking about lately, it's also understanding which data you need to provide, because we have to remember, the LLM is trained on a lot of internet data, so it has some intelligence to some extent, but has not lived your life. It has not lived your life. It's not an expert business person and an executive. It hasn't lived that kind of life. So you really have to think about what to pass in. You're gonna have to provide a lot of data that may be obvious to you, but the LLM, you know what I mean? The LLM is trained on such limited knowledge, really, relatively speaking, right? You can imagine, one thing I was thinking about is, how does this compare to our human experience? It's like, yes, I can tell the LLM as much as I can in text, but there's so much information that we process as humans that I couldn't even put into text. Right. So imagine if you've been in business for 10 years, 20 years, it wasn't just documents you analyzed. It was those meetings you were in. It was reading the people you're around. It was the feelings that happened. It was the getting to know the people. So it's all these things that actually are hard to put into text. So my point being is, remember, an LLM doesn't have access to any of that. It literally only has just text. So what I'm trying to say is, be very mindful about providing enough information to your LLM. Make sure it's clean, but also you're probably going to have to provide a lot of it because it just doesn't live as complicated of a life as you.
Yeah. Yeah, no, I think that's rightly said. Like having a right quality and like what data set you're providing
Yeah.
it, choosing it wisely, whether it be uh, the images, whether it be just like language,
Yeah.
just generated text. Um, I do want to also, because I think that bleeds into, you guys did some work related to the XLM,
Yeah. Yeah.
XLAM, and the Atlas
Yeah.
Reasoning Engine.
Yeah.
I think now would be a good time to actually talk about what was the work and the research
Yeah.
that you guys did on that.
Sure. So the model was called XLAM, and the reason we called it, which is how you said it, XLAM. The LAM has a meaning. That's why we put it there. It stands for Large Action Models. That's why we named it XLAM. So, and yeah, this XLAM model, these are these open source models that we developed that are experts at function calling. So when we talked about this earlier, that agents, the key for agents, the thing that makes agents so brilliant is that they can take action. And these models are particularly good at taking action. And we've actually shown that our models, they're open source. They actually can beat even the state-of-the-art LLMs at taking action. So we're on public leaderboards, beating all the big name models on these taking action type of tasks. So yeah, so another interesting thing about our models is we're really excited about small models. I think that's going to be a big part of the future for AI. So we didn't
And what
only
is a small
train.
model?
Yeah, so a small model. Yeah, so the way we talk about model sizes is in the number of parameters it has. So these models, they're ultimately deep neural networks, and there's basically a lot of weights or a lot of numbers attached to. There's a lot of there's just like a lot of weights that are attached to I guess each node in this deep neural network, and so there's another to keep it pretty high level, there's a lot of math that goes on in order to get a final answer. So anyway, the way we quantify a size of a model is number of parameters, number of weights. Now, so when we say a small language model, we mean a model that has probably there's no formal definition, but I would say probably less than 8 billion parameters. To put that into perspective for you, I think if I remember correctly, models like GPT-3, which I think they did tell the number of parameters for that was around 175 billion parameters. Wow. And why does this matter? Because each of those numbers need to be stored on a computer. They have to be stored in memory. So that's where we're talking about. That's where we're talking about resource consumption. So if I have a small model, I don't need as much resource to run it. It's going to be faster because there's less math to do than in the big models. So we are really excited about smaller models. We think for efficiency, for speed, for sustainability. So we didn't only just train big XLAM models, we trained small ones, even ones that can fit on phones. Yeah.
That's I think what you said right there has so much of a big potential, because if you talk about like sure, if you are working on like a very large enterprise like Google, even Salesforce it's a large corporation, right? Then it makes sense to have like a large action model or like large LLM model, even train your own. But when you're talking about like enterprises, like small to medium enterprises, like even mom and pop shops, they don't care about like so much resources. You care about the small parameters that you're talking about. Like they care about what is in it for them, so that they can store in their own device.
Exactly.
It be their laptop or phones or anything, and they can still get the required output. And what they need is very small. They don't need like that massive output.
Exactly. So I think my thought on all of this is like every model has strengths and weaknesses. They should all be in your portfolio. We should be considering large models, small models, and look at the use case and see what's needed. But I will say that I could still see small businesses and everyone still using the big models for some open-ended tasks. But if the task is pretty constrained, do you need the world's biggest model to help you with it? Not necessarily, right? You might be fine with this smaller, compact model that you can own. You can just have complete control over this model. Right. So that's the beauty of these small models. It just opens up that new door now. It's not just, okay, I have to pay, I have to pay a third party anymore. It's, maybe I have some tasks I am paying a third party. It's an amazing model. But then I have these tasks that are like more straightforward. I want to own my model. Maybe it's dealing with private information. I don't want to send it to the third party. So now I have these small models as well.
And I mean, to tag along to privacy, I mean, GPU is a big one.
Yeah.
Not a lot of people have like expensive GPUs or like 65 GPUs stored in their warehouse. It's the GPU is limited. So how can you make the most out of your AI system with the help of the limited GPU resources that you have got with the help of smaller models, right?
Exactly. And some people, a lot, laptops, Phones, smartwatches,
Yeah.
other devices have maybe not even GPU at all, right? Sometimes it's CPU only. So um, we're seeing there's some ways to run some of these models if they're small enough only on CPU. Yeah.
Yeah, and I mean, I wanted to discuss this later, but I think right now is a good time to talk about device AI.
Yeah.
And just for audience's context, correct me if I'm wrong, but like devices AI is what you're talking about, like an AI that can be stored in like your
Yes.
phone or,
Yeah.
or your laptop or your just like the smallest devices you can, like an even watch, Apple Watch,
Yeah.
or so those are the devices which you are saying, which I think you are doing. This is the research work you are doing
Yeah.
or
Yes.
developing. So I want to touch base on that because I think
Yeah.
that has the maximum potential right now because nobody can carry like laptop in their pocket, but they can
No.
carry Apple Watches or even those
Yeah.
small devices which they can speak to and or phones. So let's talk about that. Like, can you tell us like how the AI systems are developed for those devices and what are you
Yeah.
seeing in your own research work on that?
Yeah. Yeah. First, I actually want to clarify what you mentioned this point well that the models are on the device, but for the listeners, I want them to understand what that means. What we mean is the actual model weights, the parameters, all the operations that takes to produce an output. Those are all stored on your device. So
I
it's going to
see.
take up space. It's going to take up CPU. It's going to take when you use it, it's going to take up GPU. It's going to take up storage on your phone.
Let's talk about the
Yeah.
storage because what you are
Yeah.
describing to me is so right now, let's say suppose I have a cell phone, right? So my cell phone has almost like a chip. And
Yeah.
that chip is currently designed just for the phones. I mean, that chip cannot be used in my laptop, and my laptop chip
Correct.
cannot be used in my phone.
Correct.
What you are describing is that almost like an AI chip that can be planted in the phone, or like or like some sort of like a chip which is
Uh,
more advanced.
they
And
have these. Yeah. I mean, I'm seeing more of these coming out. Like I think Qualcomm has some chips, and you'll see a lot of specific chips. But what I'm saying is agnostic to any of those chips. Like across all the different variations, Apple has their own, Android has their own. Across all these, we still want to be able to get models LLMs on the device. And so but what I want to go back to the point that I was talking about to share with the audience is that imagine you don't have these models on your device, which is the case right now for most of us. If you go to ChatGPT, you go to the app, and you have internet, what's happening is that anything you put in that app gets sent to their servers for processing. So the processing is happening somewhere else, away from your phone, which means your data is sent away from your phone. Now, imagine you turn the internet off on your phone. You're in the airplane, you're in airplane mode. Guess what? If you open ChatGPT app, it wouldn't work. You need the internet because you need the internet in order to use it because it's not on your device. Now, but again, going back to what I said, those weights actually on the phone, you own the model is there with you. So if you had like a mini ChatGPT or it's another great model on your phone, internet off, anything, you could use it. And not only that, your data doesn't go anywhere. Your data just stays on the phone where it belongs. So that's it.
interesting.
So I hope, yeah, I want to share that illustration so people really understand the impact of what it means to have a model that you own and that's on your phone.
Oh, okay. So I think, and to give you to give an example, I think people talk about like having there's a concept of like having a doctor in your pocket with the help of
Mm,
AI. So that
yeah.
means that you can have like all the diagnosis done by AI,
Mm,
but all of this information without instead of sharing with like Chat GPT or
yeah.
Perplexity, what you're doing is that you already have the mini Chat GPT
Yes.
or almost like a weighted
Yeah.
model on
Yes.
your device, and
Yes.
that device has all the information about you already. So
Yes.
you all you're doing is just asking it rather than asking an external server.
Exactly. 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 So that has, as you can imagine, that this is the reason why this area is starting to heat up because
Yeah,
we love agents now. We see the benefits of agents. Now let's have now I want agents for my personal life or on personal devices. Now that becomes a problem because do I want to send my pictures to a third party? Do I want to send my tax documents to these third parties? No, I want an agent, but I want the agent to navigate my data and not give it to anyone. So
Yeah.
that means I need the model to be on my devices and live on my devices.
Yeah. Apart from like having a doctors in the pocket, like what other use cases do you think that this can it immediately provide benefit to
Yeah.
society?
Yeah, I think more and more are emerging, but one use case that I've been thinking about is this offline use case. So internet right now is, internet, at least in the US, is pretty okay, but there's a lot of areas, rural areas in the US, and especially around the world, right? Where internet is not stable. So you can imagine it's not stable or even non-existent, right? So with the model on your device, you don't need internet access to use it. So this could actually enable AI use for everyone around the world.
Yeah, another use case I can think of, right, when you said that, is education for like
Yep.
underprivileged places like
Yep.
Africa, and a lot of like
Yep.
cities in India uh, don't have that much internet, or have internet like with limited
Yep.
capabilities. Although things are changing now,
Yeah.
but still, like you need to know, or you need to have
Yeah.
like almost like an offline model
Yeah.
uh, with proper AI systems that can
Yeah.
help you educate and still get connected to
Yeah.
still have connection to the world.
Yeah, exactly, exactly. And like I said, we're always thinking of different cases, but I would say, if you were to think about where on device might fit, are there use cases where having AI offline matters a lot, then you want to consider it. Second, I would say privacy. That's the other big driver. Are there areas where, and I mentioned this example earlier, are there areas where you want your agent or even just the LLM to work with private data? In that case, you definitely want that model to be on your device. Yeah.
Yeah, and I mean, we're talking about cell phones, but it can be any device that you want. Like
Yeah.
an IT department of a small enterprise company can
Yeah.
use like an AI system locally run on their edge
Oh
case,
yeah.
so they don't have to rely on like ChatGPT or any other. I mean,
Yep.
imagine like healthcare. So much of
Oh
the
yeah.
data in healthcare is like private data. They cannot
And it
like
can't be
release.
shared anywhere, right? It has to
Yeah,
stay like in the location. Yeah. So that's a great example. Yeah.
yeah. Like I mean, yeah, I'm seeing so many use cases for having like a
Yeah.
almost edge AI system that is
Yeah.
run on local devices rather than
Mhm.
running on servers. But
Yeah.
then why build this big of a data center like everywhere? Like why are the companies investing so much into those and not investing into like those these smaller
Mm.
models that can be fit in the devices?
Yeah. Well, I think the big models, they have their strengths, they have their benefits. Like I said, you should think of these as part of your portfolio. The large models are amazing. They're large for a reason. So they're large for a reason. The fact that they have so many parameters and the fact that their neural network is so big in that sense means they have such great capacity. They can do a lot of different things, right? You can see how amazing they are. So the large models definitely have a place. And of course, they're expensive to serve, which is why only so few people actually own them. As to your point, why only a few companies can really own huge data centers to serve these, right? So so they definitely have their place. I would say that the small models, it's it has benefits. It has the benefits that we just talked about, but I don't want to make it seem like such an easy switch. The fact that they're smaller means that they're not going to be the jack of all trades like the big one. So I want to
Mm.
make that very, very clear that it's comparing apples and oranges. So the
Yeah.
small models, they're going to be good at a handful of tasks, whereas the big models are going to be great across the board on things.
Yeah, you can call it like a difference between like a niche market and
Yeah.
a generalist market almost.
Yep. Exactly. Yep. Exactly. So
Yeah,
the small model is a specialist. The big one is more of a generalist.
yeah,
They have their trade offs. They have their pros and cons.
yeah,
I think there's a place for each one of them depending on the use case.
yeah. No, I think that all makes sense to me now. I mean, both of them have their own importance depending on what task you wanna
Yep.
perform. You can select the most appropriate one. For the most cases, I have a feeling that the small model still outweighs in terms of advantages for personal use cases. And
Yeah,
you're talking
yeah,
about, like, if you want to solve like climate change, that's definitely, you're
yeah,
talking about like as much large of a compute as you can get, so to can
yeah,
solve the complex
yeah,
uh, element that goes with
yeah.
the climate change. But if you're talking about like education for somebody who's in Africa, who doesn't have that much resources, but he or she just wants to learn about AI, or like
Right.
how the computers work.
Hmm.
I mean, for them, yeah, smaller models, like, and there are like 8 billion people out there, right? So the smaller
Yeah.
models definitely has more advantages and benefits for individuals.
Right. Definitely.
Let's also talk about AR glasses. So
Okay.
this one is also dear to me, because if you think about it, we're talking about device AI. We're talking
Yeah.
about like then augmented reality headsets, right?
Yeah.
So
Yeah.
I mean, even Mark Zuckerberg and so many other people have predicted that the next frontier of smart devices is AR headsets, which will even replace smartphones.
Mm.
So, do you think that
Hmm.
there is a potential that we can fit in the device AI, or the AI systems that you guys are building in, with some having some
Yeah.
spaces allocated that just for that?
I think so. I mean, I would imagine that has to be part of it. Like it could be, of course, there could be some things sent to a cloud, but I think there pretty much has to be, if there isn't already, some sort of model, even if it's a small model, on these devices for quick computation, for quick analysis.
Any other research work that you guys are currently pursuing that you want to talk about?
Sure. Yeah, I think one important area that we're really focusing on is agent evals. So we've heard that, 2025, you've heard from many execs, is the year of AI agents. I think that's true, but I think it's really the year of agent evaluation, because a lot of us, we're starting to deploy agents, we're starting to get hands on with agents, but we're finding gaps in the performance. So there's a lot of work to do there. My team has released a couple of pretty interesting works on this. So one thing we released is called MCP eval. So this is completely open source, completely free, so people can check it out. It's a framework to test agents on MCP servers. So,
Sorry, I'm gonna
yeah,
cut you off. So let's break it down for the people who don't understand.
sure,
What
yeah,
is an evaluation and for agent, and what is MCP2?
yeah. So when you so what is agent evaluation? So it's how we measure how good an agent is at actually doing the the target tasks. So we have to have some kind of way to measure this. We can't just, I mean, especially, right, if the LLM is the brain, you imagine, an LLM can hallucinate. It could be making up things. It could be causing errors. We don't know. You don't know what's really happening until you have a way to put in a task, look at the output, and check that output to make sure it's reasonable. What we want to do is come up with data sets that look like that. Data sets that are a bunch of tasks with a bunch of the solutions to that task, like what the agent should do. And we want to grade our agent basically on that. So what I'm saying is that the year 2025, we need a lot more of this. We need a lot more of this because we're deploying agents, but we're seeing that there are areas where, we need to improve the performance. So in order to improve performance, you've got to measure where you are and then go from there. So that's why these agent evals are key right now.
Yeah, I mean, you can only manage what you can measure, right?
Exactly. Yeah.
So it makes sense that you have to create some sort of evaluation. And then you also mentioned MCP, that is, I believe, Model Contextual Protocol, which was released
Yeah.
by Anthropic
Yeah.
Claude, right? So how are you using that?
Yeah.
And is that being used for evaluations too?
Yeah. Let me explain again, high level. MCP, it makes it easy for agents to use to navigate and use external apps and programs and things like that. So, for example, a company could have an MCP server which contains all the different functions, all the different navigations that are possible within their own app. So so imagine now an agent could access lots of MCP servers now very easily. So now it has access to lots and lots of tools, which we talked about earlier. An agent really needs access to tools. So what MCP eval is this framework we released so that you can actually test your agent's abilities on these different servers.
You have done so much research work, and of course
Yeah.
you have hold like a PhD. Like people talk about like PhD. Everybody lot of people want to do PhD, but a lot of people don't understand what goes actually while pursuing PhD. So could you please give
Yeah.
a little bit background into like what does the day to day look like for having a PhD? And you have done PhD in the mathematics. I would love to know why you chose to do PhD, and
Yeah.
if you can talk a little bit about that.
Yeah, so the PhD, I think it's a long road. It's a long road. If you want to, I think it draws people who want to go very, very deep in a topic. So you have to really want to go deep in this topic. I mean, you're spending a good chunk of time. It could be anywhere from probably 4 to 6 years, I'd say, probably 5 being the average. This is how long it takes. So it's a long time going deep. And so the typical breakdown for a PhD is you're spending the first 2 years doing a lot of classes. And these are grad level classes, so they're going to be more challenging, more deep than undergrad classes. And you actually do get a master's degree on the way. So your PhD includes a master's degree. And so that's the first 2 years, but that's not really what makes a PhD special. It's those 3 years after those 2 years of classes. You no longer have classes, but for 3 years, what you're working on is you're building the skill of innovation. You're learning how to assess what's been done in the research, find gaps, propose solutions, prove out your solutions, publish these solutions. You're working with your advisor, but you're working with peers, you're working with other experts in the field. And this is like a 3-year long journey of just diving deep in a topic, but not just diving deep in the topic. It's really about inventing new things in the topic.
Yeah, yeah, and I mean, typically researchers are very underrated because people don't realize it because they are not the people who are actually, they are not like salespeople, right? They are not
Yeah,
your
yeah,
typical entrepreneur who can
yeah,
sell things and like show off their capabilities, and you can be like next Sam Altman, right?
yeah.
Because you are really good in selling things or convincing people to buy things. So researchers, I have huge admiration for them because most of the innovations that has happened is because of the help of the
Mhm,
research work that
mhm,
goes on. And
mhm.
like you said, you have to dedicate so deep into just one topic for few
Yeah,
years. And now,
yeah,
especially nowadays, you have so many different directions that you can go into, and you have to
yeah.
focus on one thing. That's like hard.
Yeah, yeah, and it's different. It's interesting. I just think times have changed because I also think about if I were making the decision today, or if others are making the decision today about doing a PhD, what would be the best move? Because when I was doing a PhD, uh, the field was moving slower. To be honest, now I feel like it's like almost every 6 months, huge transformations, and not only that, industry is leading the transformations. So that's a huge flip. That's a complete turning of the page, actually. So I would say when I was in PhD and all the years before that, it was academia that was always ahead. But now that compute is the defining feature of being ahead. It's industry
Yeah,
that's
and
leading the way. So now it's deciding to do a PhD is more complicated now because you've got to think you might be, you're going to have less compute. So I have a lot of interns who are PhDs and they're fantastic. They love coming to industry because we have compute.
yeah. I mean, just a prime example of that is Meta, like Mark Zuckerberg offered like some billion, or like not billion, some
Yeah.
$1 million
Yeah.
salary to a 24-year-old AI researcher. I
Yeah.
mean,
Yeah.
that just says a lot. Like, why would somebody want to pursue a PhD in AI or
Yeah.
any other field per se if they can
Yeah.
get like industry um, exposure to it? Because that way they have the best latest resources, cutting edge
Yeah.
tools and
Yeah.
GPUs. even TPUs in
Yeah,
case of Google, right?
exactly. That's so
So
true.
why would you want to do research in some other academia? So I want to ask you, like, for the people who want to be an AI researcher, or
Yeah.
just like get into some company so that they can do research in AI. What's your recommendation? How should they go about things? Because the industry is evolving so quickly.
It's evolving so quickly, and I will say that one of the unique features about the PhD is that you have that time, that it's dedicated time to train that innovation muscle to actually learn how to innovate, because a lot of industry jobs don't give you that space. There's not that many research roles if you think about it. So, say if you start somewhere else in industry, maybe you're not a researcher, maybe you're an engineer or other roles, do you have the time? It's just harder to find the opportunities to get involved with being involved in like the model innovation side. So I will say that it's something to keep in mind, that the PhD is designed for that. If you're not doing the PhD, then you kind of have to find unique opportunities that are proxy for that or kind of mimic that.
Mhm.
So what I mean, let's assume you're not going. Let's assume you're not going to do the PhD. What would you do if you're in industry right now? And you want to do more researchy type things? I would recommend, for example, contributing to open source. That's one way to, again, it helps you to, it's getting you used to and training you to generate new things. I would recommend potentially getting to know other researchers, maybe getting mentorship from a researcher. Possibly, if you have time and everyone is okay with it, even helping researchers or helping people in those roles so you can get that experience. I'd recommend reading research papers to see what research looks like and start critically analyzing it. Not just so one thing I want to be clear is not just asking ChatGPT for summaries of papers. No, I mean read the paper, because this is what we did a lot of times in grad school. It wasn't just knowing what the paper summary was. It was about critical analysis of it. It was like, why did they design the experiment this way? Why didn't they test this? Did they miss this? Or was this on purpose? What do these results really say? What's missing here? They should have done this, or why didn't they do this? Maybe that's a good idea. Critical analysis is practicing that as well. So yeah, these are some starting points. You kind of have to get creative. I think if you're not doing the PhD, you need to get creative and finding opportunities like this that kind of mimic what a PhD would have done.
I do want to ask you, if you were to kind of use your imagination hat, and just being in the industry, what have you seen, and what are your predictions, as in what's going to happen in, like, let's say, suppose next year? By next year, do you think
Yeah.
that agentic AI will become mainstream? Do you think that we'll achieve AGI? What's your prediction on where AI is going in next few years?
Few years or next year are two different questions.
That's right. That's
We
right.
could be very, very far in a few years. Next year, I think we're going to see agents perform even better than they are this year, for sure. Like we already are. So next year, I'm pretty confident it will be another phase, an increased phase of AI agents. We'll probably see more multi-agent systems being deployed reliably. So I think that's something. What else might we see next year? Maybe we'll see more serious development for on device. I mean, I know we're seeing the models, we're seeing the frameworks and platforms to deploy, but maybe they'll be more mature, and maybe we'll see, real enterprise deployments. Yeah.
Yeah, that's gonna be a big one. We
Yeah.
need those, like we discussed, like people who don't have that much of good internet, or want to
Yeah.
just have some privacy.
Yeah.
Um, yeah, we need that. But you think that we will be achieving AGI in 2027, maybe?
I don't know.
Yeah, so hard
I
to
think it
say.
might take longer. I think I think my guess it would. Yeah, I don't know anymore. Things change so fast, but I would have to say it's probably going to be longer. That's my
Yeah.
guess.
No, I think I agree with you. I mean, people who talk about like AGI being near, they are just looking it from, I don't know what perspective they're looking on, but the world is more wider in terms of, like, I work in construction, you work
Yeah.
in more like a sales
Yeah.
Salesforce. So I mean, from our world, like, people, one thing is innovation, another thing is adoption of that
I
innovation,
know.
right?
Oh my gosh. Yeah. Yeah.
Yeah, so
Hmm.
it's like two different perspective. And I work in
Yeah.
construction. We are known to be like a slower adopting industry in general.
Yeah.
So
Yeah.
like
Yeah.
with just keeping that in mind, I think we definitely have, if not 5 years at least, to have
Yeah.
AGI such that it's encompassing all the industries out there and people all around the world. You know.
Yeah. It's a great point. Totally agree.
Yeah. Anything you want to talk about like Salesforce because you've been there for like 5 years? Like, what's the culture like? What do you like about Salesforce?
Mm. Salesforce is a great place. It's a great place. So I've been there for 5 years, have changed, I've grown quite a bit and changed in my role, right? Because I started as a research scientist now to, leading a team of research scientists. So I've been able to see a lot. I think it's a really great place. I think our research org is driving really awesome innovation for the products. And what I've liked is we're not only driving innovation for the product, we're releasing and open sourcing and publishing papers a lot. So we're also a part of the AI community driving innovation globally, even. So I've really enjoyed that.
Yeah, and I mean it's so good to see that a company who is much more just a normal enterprise, like in having a lot of researchers in their team
Yeah.
and leading with R&D
Yeah.
and
Yeah.
um, then going about it. I think that's very good to see. Let's also talk about like the ethical concerns. I know that there are so many different. I mean, with agentic system, it's still better than like a normal LLM. But like, do you foresee any like ethical or technical challenges when it comes to the agentic AI systems?
Yeah. I think there's so many challenges, which I hope, we'll see progress on in the next year or so. But just regarding technical challenges, one thing I want to bring up is latency, is speed. That's one thing that you'll probably see across the industry right now. It's really important because as we're deploying AI agents, remember that AI agent, going back to what we talked about, is calling the LLM over and over again. Each time it calls the LLM, it's taking time. So if an agent is doing something complicated that requires, say, 10 steps, 20 steps, it's calling the LLM 10, 20 times, and you're waiting. The customer, the end user is waiting that whole time. So one of the technical challenges that I think we'll see progress on in the next year is using a small language model instead of a large language model for a lot of tasks because they're faster. So I think that's one thing. I think we'll start to see a lot of agentic systems being powered by small models. Again, it's all about the user experience. The user puts in a task, they'll just get the result faster. Yeah.
Yeah, that's rightly said. I mean, that's another propulsion of why smaller models are more beneficial
Yeah.
for more wider use cases.
Yeah.
Okay, well, I have like one last question for you.
Sure.
I wanted to ask, what advice would you give now that you have been in the AI ML space for so long
Yeah.
and being a researcher? What advice would you give to the young, generation who are just starting off, just learning about AI, or just people who
Yeah.
want to just learn and be curious about
Yeah.
this industry and where it's heading?
Yeah. So I think first advice I would say is if you're not already experimenting with AI, definitely start experimenting with it. Of course, the entry level is ChatGPT. Start using that, seeing where it can help you in your daily life. But then explore the other ones, right? There's Claude, there's all these other great models. And I would say not once you get to a level where you're comfortable and you see the value, here's a big challenge. I want more people to start understanding how it works under the hood. So go beyond a shallow understanding of what it does, understand how it actually works. So just consider taking a class, or there's so many free resources now on how does an LLM actually work under the hood. That will give you insight as to how ChatGPT works, and it will actually teach you what to expect, like what you can expect from LLM versus not, right? So I think that's one step I would say. And then once you understand how it works, I want to also encourage people to be a part of the building process. Be a part of the building process. Contribute to. Oh, there's a lot of open source models on Hugging Face. You could probably even train your own or fine tune your own and put them on Hugging Face as long as they're small enough. A lot of laptops or limited compute can do this kind of things. Contribute to building these AI models, because we need people from all backgrounds and all voices to help build AI, not just use AI. We need people to build AI.
Yeah, I mean, that's such a great advice. Like, if you think about it, we humans, I mean, learn the best either by visualizing or by doing things,
Yep.
And so the best way, you can learn is by doing, and by doing, you're contributing. At
Yep.
the same time, you never know, whatever you're building might be something that people want, and then you can build a really good
Yeah,
product out of
exactly.
it, or just like use it for your own personal
Yeah.
use case. And
I want to give one other piece of advice too. I want to say that each person, each one of us has unique expertise already, right? Even if you're not, doesn't matter if you're working in AI directly, wherever industry you're working in, you already have expertise about that industry. I want you to consider taking your expertise and working with people potentially who have the AI building expertise. I want to say that because a lot of people don't realize that the way to make AI effective is if it's specific to the domain, if there's domain knowledge in the building process or in a fine tuning process or even in the prompt engineering process. And the thing is, people who are building models aren't domain experts, right? So my team isn't a domain. Well, I mean, of course, we're learning about domains as we go along, but we're not inherently domain experts. We're inherently building experts. So my team, for example, we work with different products. Like we'll work with your data platform people or our field service or sales people, and use that information to help build a model that's actually effective for customers.
yeah,
So I also want to throw that out there that even if you don't have any hands-on knowledge to, get in the weeds with these models, your domain expertise can still be extremely valuable for creating unique and effective AI products or AI models.
yeah, yeah. And if I can tag to that, I mean, there's a really good agent tool out there called Cursor. I don't know if
Mm-hmm.
you call it like an IDE or like a fork or whatever, but it's
Yeah.
really good. I feel like it's a really good agentic tool because, to your point, if you are the subject matter expert or at least know a lot more about a specific industry, you
Yeah.
can use Cursor. You can download the Cursor.
Yeah.
You can at least get started for free, but then it's like a $20 monthly
Mm-hmm.
subscription. But you can use it for just building your own AI agent, and then
Mm-hmm.
you can show it to your coworkers, or even just
Yes,
like
exactly.
the teammates, and then you never know, your company adopts that AI agent
Yes.
because you were able to build it. And nowadays it doesn't take that much time to build AI agent if you have the knowledge, and if you
Mm-hmm.
know how to use tools like Cursor
Exactly.
or Windsurf. Yeah,
Exactly. That could be a great prototype that who knows where it could take off. You never know.
yeah,
Yeah.
totally. Well, Shelby, I think we're coming to the end. I do
Awesome.
want to
Yeah.
say I have learned so much in this just 1 hour conversation. I'm super excited, especially about the device AI, I want to say,
Yeah.
and where the potential of the smaller models lie in the
Yeah.
next coming year or two. Thanks a lot for imparting all your wisdom, and thanks a lot for coming to the show. It's been a pleasure.
Awesome. Thank you so much for having me. Take care.
Awesome. You too. And to your audience, thanks a lot for tuning in. I hope you guys get some valuable lessons out of this. If you guys have any questions or comments, feel free to leave it in the comment section. And if you guys have any recommendation for who you want me to invite to the show, please feel free to reach out. Take care.